Hey boys and girls, so today we're going over Unit 9, Lesson 9, which is Mixed Applications of Trigonometry. All right, so that's going to take everything you've learned in this unit so far and put it together as one big review lesson here. All right, before we get started, make sure your name is at the top. And then I also want to make sure that you're adding this to the top of your paper as well. I would say about 90% of the questions you complete today, you're going to need to know all three parts that I've written up top to completely answer those questions. Only a handful, maybe you'll just need SOHCAHTOA, but many of them you're going to need to remember. We're answering the question because sine of A equals cos of B, and angle A and angle B are complementary. That's what's allowing us to, again, use this SOHCAHTOA, this trigonometry that we are learning. All right, let's look at the do now. It says, determine the measure of the marked reference angles, A and B, to the nearest tenth of a degree in the following right triangles below. So I'm just going to underline the question like usual. So it says, determine the measure of angles A and B to the nearest tenth in the following right triangles. The fact that these are right triangles is allowing me to use this trig, that's SOHCAHTOA. All right, I went ahead and I already marked, if angle B is my reference angle, 20 is the opposite, it's right across, and then always across from that 90-degree angle is the hypotenuse. I did the same thing on this triangle over here with reference angle A. Right across from that 90-degree angle is always the hypotenuse, and 7 is right next to angle A. That means it is adjacent. All right, so now I'm going to get started here. If I'm using opposite and hypotenuse, that's going to be the sine function. So here I go. If I'm finding sine of angle A, I know that sine is opposite over hypotenuse. The opposite side is 20, the hypotenuse is 21. Now this is a little different. I know that usually we try to make this into a fraction, so we have a proportion, but that's when I know what the reference angle is. Here I don't know what it is. So when I don't know, this is going to be that second sine function. So in the calculator, you would press second sine, and it's going to look like this on your screen, sine to the -1. All right, so you're going to type in 20 over 21. All right, close that parenthesis, press enter, and you're going to get a decimal. It's going to say 72.24, blah, blah, blah. But I know that I need to round to the nearest tenth because, again, I read those directions carefully. 10 has 1 0, so I want to go one place after the decimal. 5 or above, give it a shove. 4 is not 5 or above, so this guy's going to stay. So I know that the measure of angle B is 72.2 degrees. Don't forget, that's an angle that we are finding here. All right, let's look at the next guy. Same thing. I just got to look at my SOHCAHTOA here. What uses adjacent and hypotenuse? Well, that's going to be the cosine function. So here I go. Cosine of angle A is going to be the adjacent over the hypotenuse side. The adjacent was 7, the hypotenuse was 10. Again, I'm looking for the reference angle, so you will not make this into a proportion. Instead, on the calculator, I'm going to type in second cos. And again, it should look like this, cos to the -1. You're going to do 7 over 10, close that parenthesis, press enter. All right. On your screen, you should see 45.57, blah, blah, blah. Again, I'm rounding to the nearest tenth. 10 has 1 0, so I only want to go one place after the decimal. 5 or above, give it a shove. This is 5 or above, so he will get a shove. So I know that the measure for angle B is actually going to be 45.6 degrees, okay? And again, if you are not getting these numbers, guess what? It's because you are not in degree mode. All right, make sure that you are in degree mode before you use any of these, before you start working on any of these questions. All right, or else you're going to get the wrong answer. All right, let's look at number 1. It says, let me move all the way up here actually. Okay, determine the value of x, which makes the following statement true. Well, if you look at the notes that we wrote at the top of our page, I hope you guys did that. It says that sine of A equals cos of B. All right, it also says that A and B, those two angle measures, are complementary. Again, we wrote it right here at the top of our paper. So what do I know about angle A and angle B? They add up to 90 degrees. That's what complementary means. So down below, when I'm solving this, I know that 73 degrees plus whatever angle X is going to be should make 90 degrees altogether. All right, and when I solve that through, we get 17. So here we go, determine the value of x. Well, we just did. X is going to be 17 degrees. How do I know it's going to be 17? Make sure you guys write this with me because angle A and angle B are complementary. Again, that means that they add up to 90 degrees. It's the only reason we're allowed to do this trick here. All right, number 2. Is the sine of 62 degrees going to be the same thing as the cosine of 28 degrees? Explain. Well, I'm going to use that same strategy I just used on number 1. I know that angle A, when I add it to angle B, those 2 degree measures should make 90 degrees. So I'm just going to check. Is 62 plus 28 90 degrees? Is it going to be 90? Well, when I add it together in the calculator, I do get 90. So it works. It checks off. So are these two guys going to be equal? Make sure you answer the question yes. Yes, they will be equal. Explain, explain. Make sure that you answer the question completely. Yes, they're going to be equal because sine of A equals cos of B. Sine of A equals cos of B. How come sine of A equals cos of B? Because angle A and angle B are complementary. All right, guys, these are a married pair. They cannot be separated. You cannot write one without the other. Same thing, if you write this at the bottom, you have to include this at the top. All right, so just be careful. If it asks you to explain, you have to say both. All right, I know in number 1 I didn't say both. I mean, I guess I could. Let me add that on. Sine of A equals cos of B. My bad. We should have wrote that as well. But number 1 didn't necessarily ask us to explain. All right, but when it does, you have to say both. Cool, let's move on to the next page. All right, so here we go, number 3. Okay, it says in right triangle ABC with the right angle at C, sine of A equals 2x plus 0.1 and cos of B equals 4x minus 0.7. Determine and state the value of x. Explain your answer. So before I start working on this question, something I want to immediately add to the top of my paper here is SOHCAHTOA. I'm probably going to need it. Here we go, SOHCAHTOA. And I also want to write down on the side here that sine of A equals cos of B. And again, the only reason that's true is because angle A and angle B are complementary. That means that they add up to 90 degrees. All right. I know that trig can only be used on right triangles. So the fact that they're telling me this is a right triangle, that's telling me that I am allowed to use this knowledge on this question if I'm solving for x. Here's the question. Determine and state the value of x. All right, it says explain your answer. Let's underline that as well because we want to make sure we answer this question completely. So again, if I know that sine of A equals cos of B, well, if sine of A is 2x plus 0.1, that means it's going to equal cos of B. Cos of B is 4x minus 0.7. All right. And now I can just set up this equation and solve. So here I go. I'm going to just drop my train track here, and I'm just going to solve away. I want my x's to be together on the same side. I like to bring the smaller to the bigger. So I'm going to subtract 2x on both sides. Now this will cancel. All I have left is 0.1 equals 2x minus 0.7. Now that my x's are on the right, I want my numbers on the left. So I'm going to add 0.7 on both sides. This cancels. Now I have 0.8 equals 2x. And now the last step, anytime I have a number and a letter mushed together, mushed is multiply, the opposite is divide. So I'm going to divide both sides by 2. 2 cancels. So on the side here, be really careful when you type this in the calculator. 0.8 divided by 2 is 0.4. All right, so determine and state the value of x. It is 0.4. Just for time, I don't have enough time to really show the plugin here, but if you want to check your answer, you would replace x with 0.4, again replace x with 0.4, type it in your calculator, and you'll see that both sides equal each other. All right. Now it says explain your answer. Why am I allowed to set up this equation? Well, I actually already wrote it. This is the explain, because sine of A equals cos of B, and angle A and angle B are complementary. All right, so this was the explain. All right, moving on to number 4. It says explain why when cos of X equals equals sine times 90 minus X, for X such that it's between 0 and 90. Okay. Explain why cos of X equals sine of 90 minus X. So this sometimes tricks students up. What this is really saying is that cos of A equals sine of B. If you're confused by this, you just have to memorize or try to remember that's really what it's saying. It's saying that cos of A equals sine of B. So explain why that's true. Well, we've been explaining it this whole time so far. Sine of A equals cos of B because the acute angles in a right triangle are complementary. And how do I know they're complementary? Because I know sine of A equals cos of B, all right? And we've gone over this. A and B are acute angles, all right? If I have that 90-degree angle inside that right triangle, the other two have to be acute. We actually have an example of it right here in number 5. If this angle is 90, well, this is less than 90, this is less than 90, this would be A and B. A and B are acute angles. And again, 60 plus 30 is 90, right? They're complementary as well. All right, so that's just taking my explain from number 4, and it's applying it to a real question like number 5. All right, let's look at number 5. It says, find the missing side lengths of A and B in the triangle below using trigonometric ratios. Round to the nearest tenth if necessary. All right, here we go. Find the missing side lengths A and B, and then again, I have to round to the nearest tenth if necessary. All right, I have to use a trig ratio, not just because they told me, but if I'm looking for the missing side of a right triangle, we've only learned to use Pythagorean theorem to do that, and I don't have enough information to use Pythagorean theorem. So I have to use trig. So again, if you want on the side here, we should be writing out so, ka, toa. I'm gonna need it again. All right, let me move this over and let's jump on in here. So I'm gonna just pick one reference angle to use so that way I don't make any mistakes here. Okay, I'm gonna use 60 as my reference angle. So that means from